Welcome students. Welcome to the lecture number 7 of chapter named as computer networks. Okay. So in the previous lecture we have discussed about some wired transmission media, or we can say that guided transmission media. Okay. So now in this lecture we are going to study about some wireless transmission medias. Alright. So let's begin with the wireless transmission media. So basically what is the wireless transmission media? Over here the definition is written as yes. So the definition is written as the signals are broadcasted through air or water and thus are available to anyone that has the device capable of receiving them. So in the case of the wireless transmission media, we send the data in the form of signals. Okay, we send the data in the form of signals, and either air or water, they both are the carriers of the signal. Okay, so the data travels from source to the destination in the form of signals, and over here the air or water will be acted as a transmission media for them. Okay, so these are basically the carriers for sending the signals. Right. So some of the wireless transmission medias are infrared waves, microwaves, radio waves, and the satellite. Right. So let us discuss all these types of wireless transmission media one by one. So the first one is basically the microwaves. Okay, so you can see there is a diagram for displaying the microwave communication. Right. So you can see over here, it basically, this is office 1, right, and this is basically the office 2, and in between both these offices there is a microwave tower. Right. So you can see that over here one antenna is fixed, and in the tower there are two antennas fixed. Okay, so the data from office 1 first be converted into the form of signals, that is microwave signals, and then it moves from source to the destination point. Right. So this is the basically the destination point for it, and once it reaches over there, then the other antenna of this tower transmit the data further to the office number 2. Okay, so you have to just understand that in case of the microwave signals, the signal travels in a straight line. Okay, the first point is that the signal travels in a straight line. Okay, and that's why, and one more important thing, these signals are not able to penetrate any object. Okay, so in this way the receiving and the both the antennas, the transmitting and the receiving antennas, must be aligned in such a way that the signal directly transmit from the source to the destination. Okay, you can see in this diagram these two antennas, right? So this is the office 1 antenna and this is a microwave tower antenna. So these two antennas are arranged in such a way that the signal directly travels from one point to the another point without any obstruction in between. Okay, so the antennas are adjusted in such a manner. So let us see some points of the microwave transmission. The first one is the microwave has a frequency, okay, range of 300 megahertz to 300 gigahertz. Right. So this is basically the frequency range of the microwave. Okay, so when we transmit the data with the help of the microwave signals, then we have to use any one of the frequency which lies between these two ranges only. Okay, the next point is that the microwave travels in a straight line. As I already told you, the microwave signals always travel in a straight line, and they cannot penetrate. Okay, they cannot penetrate any solid object. So obviously if any solid object comes in between the microwave signals. Okay, so the microwave signal cannot penetrate that solid object, due to which the microwave signals cannot travel further on. Okay, so therefore for long distance microwave communication, high towers are built. Okay, so the towers are built for a very good height. Okay, are built, and microwave antennas are put on their top. So you can see, if you see in these diagrams also, the antennas are arranged in such a manner that no obstructions comes in between them. Okay, so if the offices are very far apart, then they basically built high height towers for setting the antennas. Okay, next point is that these wave travel in a straight line, as I already discussed in the above also. These wave travels in a straight line, therefore the sending and the receiving antennas have to be aligned with each other, right? So obviously they traveled in a straight line. So what does it mean that they travel in a straight line? Let me explain you with the help of an example. Now suppose this is my office number 1, right, and this is my office number 2. So suppose this is the tower over here and an antenna is fixed, and suppose this is the tower, right, and suppose antenna is fixed in this way. Now you can see that this antenna, according to this antenna, the signal travels in a straight line, and this antenna, the signal travels in a straight line. So in this way both the signals, both the offices cannot communicate with each other. Why? Because the microwave signal travels only in the straight line, and you can say that, and you can see that the antennas of these two offices are not aligned with each other. That's why they didn't receive any signal from each other. Okay, so what possible remedy can be performed? Okay, so in this case what will be done now? So in this case they will arrange the antenna of both the offices, like the antenna of this office is arranged in this manner. Okay, so that what will happen, the data from this office directly reach to this office, and similarly the data from this office directly reach to this office. Okay, so their antennas must be arranged in such a manner that they can straight away send and receive the data to each other. Okay, now the next point is free from land acquisition right. Okay, so it's your office. Okay, so you don't have to take any land or any kind of purchase any land for setting the towers, right? So it is free from land acquisition right. So as you see that, what you have to do, you have to set a tower in your building and set the antenna over there. So for that you are not purchasing any land, right? So that is free from land acquisition right. And the last one is the relatively inexpensive than wired media offers ease of communication over difficult terrains. Okay, so it is basically inexpensive than the other wired medias which we have discussed in the previous lecture, right? And the next point is that ease of communication over difficult terrains, right? So where there is a problem in setting the wired cable, in those situations these microwaves, that is wireless medium, is most suitable. Okay, suppose if we talk about ships on sailing on the seas, you can see that how they communicate with each other. Obviously there must be some communication medium. So in case of sea, it is not possible to set the wire network. Okay, so in this case the data from one ship to another ship is sent through microwave signals. Okay, so these are the benefit of microwave signal, that is that with the help of microwave signals we can set the communication at those places where the communication is not easy, it is very difficult. So at that point of time we can use the microwave signal to set the communication between the difficult terrains. Okay, now the next one is basically the radio waves. Okay, as you see, the microwave travels only in the straight direction, but that is not the case with the radio wave. the radio waves travels in any direction. Okay, so that's why we call radio wave as omnidirectional. Omnidirectional means it can travel in any direction. Second point is that it can penetrate any object, right? The radio waves can penetrate any object. So that's why, you know, in our mobile phone, for mobile phone communication, radio waves are basically used. So let us see some points of the radio waves. Okay, so over here is the radio wave transmitter, and you can see that this transmitter is basically sending the signals in all the directions. Okay, so the signals is sending in all the direction. It is not that the direction is sent only in one direction. No, the signal is sent in all the direction. That's why we call it as omnidirectional, right? So the points of the radio waves are: the radio wave has a frequency of 3 kilohertz to 3 gigahertz. So this is basically the frequency range of radio waves. Okay, so all the signals which were used for sending the data using radio waves use the frequency in between this 3 kilohertz to 3 gigahertz only. Okay, so this is the frequency range. Radio waves are easy to generate and can travel long distance and can penetrate building easily. That's why they are widely used for communication, both indoor and outdoor. So as you can see that radio waves can penetrate any object. Okay, so that's why it is basically preferred for communication both indoors and outdoors. Okay, suppose if you are sitting inside your home and you have a mobile phone, so obviously you can make a call from your mobile phone, or you can also receive call from your mobile to your mobile phone. Okay, so what does it mean? The radio waves signals that is coming out from your mobile phone when you dial a call can penetrate the walls of your house and moves out. Similarly, if someone is calling you, then the radio wave sent by that person will penetrate your house wall and reaches to your mobile receiver. So it means the radio waves signals can penetrate any building, right? So the third point is the cordless phone, AM and FM radio, garage door operators, etc. are some of the example of radio wave transmission. So there are many devices in which radio wave transmission is used. These are some of the examples, right? These waves are omnidirectional. As I told you, the waves can travel in any direction. So the transmitting and the receiving antennas need not to be aligned. Okay, as you see in the case of microwave, I have explained you that the receiving and the transmitting antenna should be aligned with each other, because the microwave travels only in a straight line, but that is not the case with the radio wave. Okay, so these waves are omnidirectional, so no need to align the receiving and the transmission antennas with each other. Okay, so that is not the case with the radio waves. Relatively expensive, that wide media and offer ease of communication over difficult terrain. Obviously, suppose I give you an example that a person wants to set a network in a hilly area, right? So one in the hilly area, the whole city are established between different hills. All right, so suppose the office has to set his 4 offices. The company want to set his 4 offices, and these offices are situated at the different hills. So how they can set the network between all the offices? So obviously they will use the radio waves, because they can penetrate any object which is coming in the line, right? And also these are omnidirectional, so we don't have to align the antennas with each other. So for setting the network in a hilly area, radio wave communication is the best one, right? And also the permission from concerned authorities is required for use of radio waves transmission. Okay, but as you see that in radio wave transmission you have to take permission from the concerned authorities, right? So as you see, suppose Airtel is providing us the mobile facility. That means Airtel is using the radio wave communication medium, right? So obviously he has to take some license, some permission from the communication authority. Only then he can conduct the communication using the radio waves. Without the permission, without the license, he cannot do that. So that's why permission from concerned authority is required for use of radio wave transmission, right? So I hope it is clear to you. The difference is that the microwaves travels in a straight line, right? They cannot penetrate any object. So that's why the antennas of receiver and transmitter must be aligned with each other. Whereas radio waves can travel in any direction, they are omnidirectional, and also they can penetrate the objects also, right? So that's why no need to align the antennas. Okay, so radio wave transmission is more preferable where there is a situation that we have to penetrate some objects. So in that case, radio waves are basically used. And as the last point is that it is a less secure mode of transmission. Obviously, if the signal is traveling in open air, right? So obviously, if someone can trap that signal, then he can get the message. Okay, so that's why it is a less secure medium of transmission. Now the next one is basically the satellite. So in that case, you can see that suppose if two offices are present at different location or different point of the earth, right? So how the communication can be performed in between these two? Because they cannot send data directly, because if this office will send data, then obviously this data will end at this point. Okay, so what they will do, they use a satellite for it. Suppose this station that is situated at Europe and the other station that is situated in Asia. So this station wants to send some data to him. So what he will do, he will send data to the satellite, and then the satellite will send the data to the next station. Okay, so when the earth station sends data to the satellite station, we call this procedure as uplink, and when the satellite sends the data to the earth station, this is called as the downlink. Okay, so you have to just remember these two words, that is uplink and downlink, right? So the characteristic of transmission using satellite link, obviously satellite covers larger area. I hope you understand that how satellite covers a larger area, because you can see that the satellite is at the top, right, at the orbit of our earth, so it can cover a larger area. Okay, the next point is, since communication over very long distance is possible in case of satellites, so this become a commercially attractive options also. Now you can see that suppose I give you an example of Star TV. Okay, all of you know that Star TV is available all over the world, but how it is possible? Because in this case, the Star network sends their signals to the satellite, and the satellite sends all those signals to different point on the earth, right? So that's why the Star TV network will be seen in any part of the world, right? So that's why this becomes commercially attractive option. Why? Because it covers a very long distance. Okay, and obviously the system must be expensive because it used the satellite for the communication, so that's why it is an expensive one. And the next thing is that obviously it requires some legal permissions also, because if a company has to use the satellite, then he has to do all the paperwork, follow all the formalities for starting its communication through the satellite. Okay, so require legal permissions also. So the next one is basically the infrared waves. Okay, let's see what is basically infrared waves. You used remote controls, okay, for operating your TV, for operating your AC. So all these devices uses the infrared waves, right? Okay, so all these devices use the infrared waves. Okay, first thing, they cannot penetrate any object. Okay, suppose if you are watching a TV and if your brother or sister comes in front of the TV, okay, and if you press the remote control button, then nothing will happen. But once you move away from the TV, after that, if you press the button, then the TV will operate. So why it is so? Because the infrared waves cannot penetrate any object. So that's why when your brother or sister comes in front of the TV, the signals from your remote control is obstructed. Okay, so they cannot they are basically stopped when they reaches to the person standing in front of the TV. Okay, so on one more thing, there are short range, they cannot travel the long distance. Okay, so these are some examples. Like you can see that we can use this remote controls to operate the TV, and these remote control uses infrared waves. And the one best ways to use infrared light therapy for arthritis. So nowadays infrared waves are also used in handling many cases of, like you can see that in medical also. Okay, so infrared rays has a frequency of around 300 gigahertz to 400 terahertz. And then home entertainment remote control devices, cordless mouse, intrusion detectors are some of the devices that utilizes infrared communication. Okay, so these are some examples where the infrared is basically used. The next is, these waves has a major drawback that they do not pass. Okay, they do not pass through solid objects. As I told you that these infrared waves cannot penetrate a solid object, right? And also no government license is required for their use. Okay, you can use it directly, no government license is required. And it is a line of sight transmission, therefore at a time only two devices can communicate. Okay, so it means that you have to align the your remote control with the device, so that that signal straight away moves to the device. Okay, so that's why it is called as, it's a line of sight transmission. Okay, the next one is basically the Bluetooth, right? So Bluetooth is the last topic. As you all know about Bluetooth, that Bluetooth is basically a communication technique through which two devices can pair with each other, right? And after pairing, they can share their data. We can connect any device which supports Bluetooth, right? Suppose if I have a headset that supports the Bluetooth, then I can connect my headset with my mobile phone, right? And the songs which I play in my mobile, I hear the sound of those songs in my headset, right? So similarly, I can connect my laptop with my mobile, I can connect two mobiles, so I can connect any device with each other who supports Bluetooth. Okay, so Bluetooth technology basically uses radio waves, right, in the frequency range of 2.402 gigahertz to 2.480 gigahertz. So you can see that it is 402, 480, right? So one thing is that the Bluetooth uses the radio wave concept. Okay, the Bluetooth uses the radio wave frequency, and the frequency range is basically 2.402 gigahertz to 2.480 gigahertz. Okay, this technology is used for short range communication, approximately 10 meters. So you can see that if we connect two devices with the help of the Bluetooth, then we can transfer data only if these devices are placed near to each other, right? And suppose if I took one device far apart from the other device, then obviously the Bluetooth connection breaks and the data transmission procedure stops. Okay, so it means that if you want to use the Bluetooth, then obviously the devices must be around at a distance of 10 meter approximately. Okay, and line of sight between communication device is not required. Why it is not required? Obviously because it follows the radio waves. Okay, so as radio waves are omnidirectional, they, in that case, the two receiving and the transmitting antenna should not be aligned with each other. So as Bluetooth is following the radio waves, so that's why line of sight between communication devices is not required, because it uses radio waves and it is omnidirectional. So obviously it is okay that as it uses radio waves, so it is omnidirectional, and so no need to align the devices with each other. Okay, and Bluetooth can connect up to 8 devices simultaneously. So now what we can see, that Bluetooth can connect 8 devices to each other, right? So in today's class we have discussed some points, and these points are basically, the first we have discussed that about the microwave, right, and microwave, right. And what are the points that we have discussed about microwave? The points are basically that they travel in a straight line. Okay, so microwaves basically travels in a straight line. Okay, the next point that we have gone through, that they cannot penetrate any solid object. All right, so they cannot penetrate any solid object, and receiver and transmitting antennas must be aligned with each other, right. So they both must be aligned with each other so that the transmission can be performed easily. Okay, so you have to remember these points. These are just the key points for it. Okay, now after microwave we have discussed about the next thing, that is radio waves. Okay, so what points we have discussed about radio waves? So in case of radio waves, we have learned that they travel in any direction. Okay, so they can travel in any direction, so that's why they are called as omnidirectional. Okay, so that's why they are called as omnidirectional, right. And the second thing is that they can penetrate any, okay, over here it's they cannot penetrate any solid object, right. So just wait, let's just change this point. So it is microwave. In case of microwave, they cannot penetrate any object. Okay, so this is basically the important point with respect to the microwave, that they cannot penetrate any object. But when we talk about the radio waves, they can penetrate any object. So that's why it is preferable. And obviously the receiving and transmission antenna must not be aligned with each other, because they are omnidirectional and can travel in any direction. Okay, and the next that we have learned is basically satellite, right. So satellite, we call it as satellite microwaves. Okay, because they travel in any direction. Okay, and also they, for what the basic point is, that they cover large geographical area is covered by these waves. Okay, so large geographical area is covered by these waves, so you have to remember these things, right. And the next one is basically the infrared. So infrared, in case of infrared, the basic points are that they short distance, they can travel in a short distance, and also cannot penetrate any solid object. Okay, so the most key point is that they covers basically the short distance and cannot penetrate any solid object. So these are some key points that you have to remember. Okay, so now the today's lecture is over. I hope you understand what are the differences between the basic wireless transmission mediums. Okay, so just go through all the topics, and thank you very much and have a nice day.